Just from allocative and productive efficiency, and then absolute advantage. That's about it. And then capital good.
Doing good. How are you doing?
Good.
Hey, I'm just saying.
Dave's not here.
I was next week.
They do it? You have a mission to complete today.
Dude, Thursday, we're not getting in until definitely minutes. Oh,
Sure, I know.
don't be soon, Arush. I said, oh, thank God, Dave's not here.
Oh. Spoke too soon.
David, go back for you.
Yeah, but you like that straight into you.
Huh? No, Mr. Yeah. You're tolerant.
What did you say?
And you said it's not me.
I didn't hear it. I didn't hear it.
Instead of Rich making a racial comment.
Now, can you, David, could you like elaborate on what you said?
You said it's not me.
Why are you gaslighting back there?
We really have to deal with this every day. You gotta deal with
That's
that.
why. Now, the rest of you get into this. I thought you had. No, I guess.
Hey, review time.
I'm not even checking. Is they reviewed it?
Yo, review Friday.
It is? No, it's not. It's finished everyone.
No, I've taken this quiz off.
So you're not wearing that. It's honest.
Should we check pages 6 through 8? But go ahead and start on page 9. We're just going to be reviewing mainly our algebraic steps. So simply activate.
I didn't see review though.
Let me check pages 6 through 8, but while you're waiting for me to come check, start on page 9 and begin your steps for evaluating.
Six.
Yeah.
You got 6, 7.
Thank you.
It's 677, right?
I didn't think I could.
I had this, and then I went like this. Literally, like it was 6, and he goes, right? It's on the bottom.
You could probably.
Yeah.
Wait, no, this. What about the bottom? What about the bottom?
Yo, it's 31, just like.
41?
31.
Oh, wait, this is a minus.
What about the bottom? Hey, what's the move from 31?
You plug it in and you find it.
Alright. Alright. What's the square root of? Oh. Hold on.
Is -2 cubed?
Why did you have that?
Well, yeah.
Did you get 10?
I did.
Stop right now.
That much. Pages. Wait, no.
Yeah, I didn't even this. Oh, the kid.
Yeah, would you?
26. What do you mean 9?
33.
I got 13 different classes.
Hold on. Oh, wait, no, it's reduced.
He's got.
Damn it, I got 0 over 0. I got 13 over 4.
Ow.
Yeah, I can put.
Yeah.
Yeah, I got the.
Oh, wait, no, I messed it up.
Wait, if it's a parentheses, I suppose that more time in it too, right?
I got 0 over 0. This one's easy.
David, how'd you get 13 on the top big notes?
Yes, negative.
Six, and it's -6 over -2.
Yeah, that's great.
I got -2 to the third.
Oh, yeah.
Don't be negative, so it's -8.
It's -2, so -2 things.
Negative second would be positive number, negative, it's cubed, it's gonna be 3 cubed, so it's negative. So it's gonna be negative, -8 times 2 is -16. You get +10, +5 times
Oh, -16 minus 10.
-26.
How did I get? I was by a lot loose. Yeah.
Yeah.
What about the bottom? What's -4 minus 2? That makes sense.
Yeah, I don't.
Oh, I'm putting it down.
What did you 35?
Did I get 35?
Yes.
What'd you get? 10. What is going on?
Going on with the phone. David. It's -8 minus 2. -4 minus 2. That's -6. -6. All right, well, you're just gonna figure it out.
It's -6 minus 2. Where are you getting that?
It doesn't work, don't matter.
It's a 3 there, not a 2.
Talking about. Oh,
That's why I.
well. So what's the right answer? Is it on the -8 on the bottom?
Yeah, very.
Dave, what about the bottom?
Okay, everyone, page 9, go ahead and get started. Remember, your first step is always direct substitution. Even if something looks factorable or you are expecting conjugate method, never skip that first step, right? You're always having to show that there's a hole before you go into all your algebraic steps.
Oh, that's so on this one. The way I worked it out, these cancel out. That just make my final answer.
Yeah, that one was a little bit strange. Combine, add the terms together first before you go through your steps. So those are two fractions of the same denominator. So merge it into one fraction first and then go through the limit process.
And so, no, I did.
Oh, you did that, okay.
Yeah, and then I got to.
Yeah, yeah.
Just cancel out the
You
answers.
too, yeah. That's it. You got it, you got it.
You basically, you pull it, I pulled the X and then back. Sure did.
Hot horizontal.
Okay, so let me go through the first two here. So 31 and 33, there's no we don't have anything beyond direct substitution because direct substitution leads us directly to our numeric answer, real number. So 31 and 33 are just continuous functions through 4 and -2. There are no asymptotes. There's no holes. It is just the order pair exists on the function. So we don't have to worry about anything beyond that. Okay. 35 and 37, try those.
I'll go ape shit.
What's going on with 44?
What's on the 30?
39's actually chill.
Oh, 41 was fun. Dude, 41 was fun.
Oh, do you? But when you evaluate.
Don't too damn close. Landscape.
Use the coins, we have one set.
So, there is. 39.
Yeah.
You, well, these are the same, so you can just add. I just pulled the two. And then you, they.
I don't know what's the figures.
Thank you.
Okay, 35 and 37, you're confirming that there's a hole before you jump into your algebraic step. So 35, you're getting a 0/0. And then because there's a hole, now you can move into your factoring steps.
Here's the thing.
X minus 2 can cancel out. Remember that if everything disappears from one side of your fraction, it's a 1 remaining. Okay, so there's still a 1 remaining in the denominator. So then after direct substitution, you'll get 2 plus 2 over 1, which is 4 over 1, which is 4. $37. Direct substitution also indicates that there's a hole in the graph. So we're gonna go through all of our factoring steps to clean up that numerator. So factor an x out. X squared minus 1 produces x minus 1, x plus 1. Now we see the common factor that can be removed. Cancel the x plus 1s out. And then the remaining expression reevaluates, and we get to 2. Yeah.
You have to write limit every single time you.
Yeah, good question. So if there is an x remaining in your expression, that means you're still working through the problem. You need a limit statement in front. As soon as your variables drop out and you're only left with numbers, then your limit statement can be dropped. So we need a limit statement if the problem still has variables in them. Okay, 39.
What about the ball?
Combine those terms first. That way, you're able to just evaluate the limit of one fraction. So combine those fractions first. That should be easy because the denominator is already the same. So you can just add the two fractions
Calc's chill.
and then go through your limit step.
This whole page.
What about the ball? Oh, you got a little, little crap.
So 39,
There's 2.
we combine like terms. So
Yeah.
we're gonna begin our direct substitution at the next step where we have the two fractions combined. We get 0/0, factor, reduce, reevaluate. There is nothing to plug in. The only thing left is 2, so my limit will stay as 2. Okay, 41,
Oh, that's another hole.
0/0. What's our strategy if there's radicals involved? Conjugate method, yes, yeah.
Let's see. The final answer.
You close
Final.
Wait, can you add those together? Four. This is the thing we did yesterday.
Yeah.
Maybe one half.
Root two.
It's based on the numerator, correct? Okay.
Right.
So, our goal is to get the numerator to show an x minus two, because we already know what's causing the hole. There's an x minus two that's hiding in the numerator that's causing that hole. So if I were to fold this out, root x times root x is just x. Root two times root two is just, or negative root two times positive root two is just negative two. And now you're only expanding out one side. Don't expand the side that already has the hole ready to be canceled out. Okay, so leave that denominator alone. Cancel, cancel. A one is remaining up top. Right, what's our final step?
I don't know what I have.
Okay, I'll talk about that. So root two plus root two, what does that equal to?
That's what I'm trying to figure out.
Okay. Okay, let me ask you this. What's one root two plus one root two? Two root two. That's it. 2 root 2, which is adding like terms. Remember, if there's no number in front, you can always put a 1 there. It's just a hidden 1 if that helps you out.
All right.
I was convinced it was like more.
I'm saying I literally.
Yeah, me too.
All right, so now look at the back and tell me.
I'm just saying. Remind me, what's that? How'd you get X minus? Oh, because you gotta do the.
Conjugate.
Yeah, okay. But it's only the two closest ones, right? Close, and then close. Yeah. All right.
Yeah, the first pair
Yeah,
and last pair,
first- yeah,
middle
first-
pairs will go away.
Okay.
Shut up. God.
Is that a roosh talking back there?
Yep.
It's a
Always got something to say.
I got it.
God, that's.
Okay, on page 10, I want to point out a few things here. We haven't quite talked about what these notation mean. You see that negative and the positive, just ignore those. When you write your limit statement, still include those notations, but treat it like as if you're just approaching three or three. So don't do anything different with those. You're still going to find the answer, but we'll talk about what those one-sided limits mean for us later on. But right at this point, it's not going to impact what we do. Okay, I'll work through 43 as you guys try it as well.
You're over 5. Plug in that. Multiply on stage. Multiply. Yeah, you just. Wait, did you put 0? Yeah, you multiply.
Wait, no, no, I'm.
What? Okay. I didn't realize it was zeros. What did you realize it was? Every problem.
Okay, are we good so far? I'm halfway through the problem here. Yeah. So what's 4 minus 4? What's 0 times anything? Still 0, yeah. Still 0.
Those cross out. And you have 1/x plus.
Now this just makes x minus 4. So now we have, whoa.
Wait, now we have an x plus 1.
That's okay. The whole is gone. The right substitution is your final step.
We can't leave it like that though, right?
What's the final step for a limit problem after the whole is removed?
So you plug it in.
Yeah, yeah.
Plugged it.
The right substitution is your final step.
So you get 1/5 times.
Come on, give it to me.
That likes mine.
10 plus 3.
What did you do? Oh. Yeah. Oh, it's multiplying.
What did I get? Oh.
5 is like tremendous.
Guys, 45 to 50, just pretend like the one side limit is not there. Just go through your normal process like you normally would. It's not going to impact our answer.
No, it's like approaching 3 from the left, but like it doesn't matter.
Just use 3. Just use 3. Yeah.
Whoa, why is it say approaching? Why is it 3 to?
It's okay.
What? What's she for 45?
You ignore it.
That's what it said. You ignore it, it says 3 minus,
Yeah.
you ignore the limit,
You just
approaching from 3 to the left.
Yeah, it's going to be 3 from the left, going to be 3 from the right, but algebraically, it's not going to matter for us. Just plug in 3, plug in 3. No.
All right.
We haven't talked about our full one-side limit yet, but for now, it's not going to matter.
Wait, but that will be a problem soon.
For certain problems, but not for these problems. Yeah, it could, it may pose something different later on, but we haven't talked about it yet.
These are the same ones.
David, you didn't have -5 in the second one, did you?
Just have it.
All right.
What is your saying wrong?
3 times. Wait,
And like it only did 4,000.
they just forget that.
What do you have your first?
David, you didn't get a whole 47?
There is a hole on 47.
I think you're tripping, big dog.
No, there is. No, there is. I got.
Oh, I thought you said there wasn't a hole.
Sorry. I just plugged it in like.
No, wait.
Yeah. I didn't even care.
That's what I said, like 3%.
Wait, did you guys get
Hey,
sick?
milkshake.
I like 20 feet.
What does care?
I think it's a carrot.
Oh, no, I don't know who care.
I don't know about that.
I don't know, I just got. I don't know, I just got here. You guys didn't have to get 6 in that coffee, did you?
So much, like, arrow.
All right, it's the same problem. Cool. I didn't believe you till I saw it, David.
Oh, it is.
Wait, it actually is different. It actually is different. But not, because the limit's different. Uh-uh.
Yeah, number 49 wasn't there.
Right, any questions? The rest of page 10?
Wait, number 49 is like, they don't have to do anything. All right. We're like, see,
Don't get too happy. I don't know what's going on this next page.
So we like to see. David, come see.
Guys, on page 11 and 12, we're just going to pick out a few problems. Some of them are out of place in terms of problems or a concept we haven't gone over. So we're just going to work on page 11, 12, 2, 3, 4, and 6. And then I'll pick out some additional problems when we get past these. So
Wait, square root of zero, right?
but I'll stay on this page for a little bit longer. But you guys can go ahead and try page 11
Square
and 12.
cancels that out, right?
No, it doesn't, but let's do it as is.
Square root of 0.
But it's in the parentheses, so it's gonna cancel it out anyway.
It would, but it's just give me zero.
This just contributes to the, so it doesn't matter. This is 3, so you're kind of like,
Yeah.
I might be that.
What number? It's not my fault, I'm just making the same calculator.
Right.
I went down to, what'd you get at Roosh?
Wait.
Roosh.
That's kind of wrong.
Right.
Insane.
What'd you say?
Okay.
For 50?
I don't.
Everybody okay with page 10?
It's on the board.
I'm
Hold on, hold on. Hold on.
You have to like.
Oh. Totally. got it. Hey. What?
Yeah. Okay, page 11.
Cool.
Why didn't you change five minus? Multiply by negative one.
It is.
Oh, wait, it's 2?
Oh, how did you?
Hold on, 5 minus 5.
Is it not? It is 0.
Number 2 is 0, right?
Oh, hold on, figuring it out. Oh, I think David could be wrong. There could be specific.
I got it.
Did you pull the negative, did you pull the negative one out?
Yeah, you pull the negative out one out of one of the two, and you just you're
This was the right answer.
Roosh Statley was right.
Was it 0?
Yes,
Okay,
I believe so.
I believe so it is. Yep. That's it. There it is.
Okay, let me just talk about number 2 real quick. Initially, we're getting a 0 over 0, right? So next step, we're just gonna do a little bit of cleanup. Guys, so 5 minus t squared can be expanded out to be 5 minus t times 5 minus t. We do want to find the whole between 5 minus t and t minus 5. These are essentially the same expressions. They're just off by a factor of -1. If I factor -1 from either of these, they will match. I can cancel that out. So there's a leftover -1 after we cancel these two factors. And then replace any remaining t's with 5. And I'm ending up with -1 times 0, which is 0.
Did you do number 1?
No, we're just doing 2, 3, 4, and 6.
Okay.
Yeah, on page 11 and 12. Okay, are we okay with 2? Now, number 3 requires a little bit of cleanup on that numerator portion because it's tough to evaluate a limit when something is in function notation. So we do need to pull that numerator out of function notation. So replace f of x with 3x squared minus 4. And how would you go about finding f of 2? Plug 2 into the function and get that number. So after, so I kind of highlighted what you want your numerator to be replaced with. And then once you get those numerators out of function notation, then just go through your normal limit process, direct substitution, and go through the rest of it.
So what about the minus F2?
F2. So this is f of x, right? So f of 2 just means find the y value in the function at 2, which will just be, yeah.
Okay.
Just plug the 2 codes, we can see.
So you don't, use the limit. to
Not
plug
yet.
in.
I'm just getting the numerator replaced so that I can actually do the limit problem. Because right now, the limit problem is kind of, unresolved.
Whoa, David, I think you might want to look at the board, David, look at the board.
So are we okay with this initial setup? Yes.
Oh, okay.
So I'm just getting the numerators out of function notation so that I can actually work with it.
Okay.
So at this stage, now you can go through your direct substitution. You're gonna get a 0/0, and now you're gonna begin looking for a hole. Right, you're looking for a hole here. The factoring is a little bit strange. This is a difference of cubes. I'm not gonna test you guys over this, but just want to show you difference of cubes.
That's right.
We can expand this way. There's a formula for difference of two cubes. And for us, it's going to be x cubed minus 2 cubed, which I can expand out using this expression. So you won't have any factoring problems as messy as this, but this is how we do difference of cubes.
That's where I was.
Okay, let me just go through the steps. I think there are some questions here. The first thing is, well, I would like to, I know there's a hidden x minus 2 above, but I'm just gonna go through my factoring steps. I'm gonna factor 3 out first. So I'm getting x cubed minus 8. Good here. X cubed and 8, these are both, x is 8 is a perfect cube, because 8 can be represented as 2 cubed. So I'm gonna just rewrite that 8 as 2 cubed. And this is now in the form of a cubed minus b cubed. So a cubed minus b cubed can be expanded out this way, so therefore x cubed minus 2 cubed can just follow that same
You're
pattern.
such a dirty.
Arush, why are you still talking to me?
So here's my factored form, x minus 2 times x squared plus 2x plus 4. There's my hole, remove it,
Girl, that's not what that is.
and then replace any remaining x's with 2's. And you should be able to get your way down to a real number.
Like, I get how you got it, but just how did you, just like with the cubes, I feel like that'd be so much to think about.
So,
How did x cubed minus 8 turn into x minus 2?
so this is just, I mean, we're familiar with difference of squares, right?
Yeah.
Difference of squared is a minus b times a plus b.
Yeah.
This is just a different formula for a cubed minus b cubed. A little more extensive, but it's just a formula that allows us to get this into factored form. So it's just like the formula.
Okay.
That's good for this S.
So how did you go from x cubed minus 8 to x minus? Like, how did you go from there?
So are you good with x cubed minus 8,
Yeah, yeah.
x cubed minus 2?
I get what you got.
Okay. So here's my formula.
Okay.
Everywhere I see an x, I'm gonna replace n for a. Everywhere I see a b, I'm gonna replace a 2.
Okay.
So a minus b, which is the x minus
Oh,
2,
I see what you're saying.
x squared plus 2 times x plus 2 squared.
Okay, I see.
Okay, so in a cubed minus b cubed, you'll get a minus b. So that's just something you gotta remember.
Right, which you're not gonna worry about with us. We don't have to memorize it.
Okay,
And it's not gonna show up on AP.
so you're saying this problem is most likely we won't. see.
No, you won't. We're just,
Practicing just to practice.
but if I gave this problem to you, I would give you this formula so that you can use
Okay.
it. I wouldn't ask you to memorize it, so.
That's awesome. It's so good to hear.
I thought you were rude, but I'll chill on you, bud.
All right, number 4.
All four celebration. I'm so confused what's going on.
Guys, for number 4, sometimes we get thrown off when we see a constant or a variable in place of a number. But I want to walk us through this because we're going to just do this the exact same way that we normally would. And we're still gonna do the final limit. It's just that we're not gonna change anything that we do. We just have to get used to the fact that there's an S there instead of like the 2 or 3 that we're more used to. And so just like any limit problem, what's our first step?
Gotta plug it in.
And how would you plug in? What would you do? Plug in S in for X, okay? So numerator, I get F minus S. Denominator, I get root F minus root S, which is 0 over 0. So you know there's a hole, right? Just like any other problem that you've seen before. Now, what's our strategy if we have radical in on one of the sides here? Multiply by what? What do we call this? Multiply by the conjugate, right? Conjugate. What's the conjugate of the denominator?
Root X plus root S. Boom.
So now we got. Would you do anything with the numerator? No, leave it alone, right? This X minus S is what we want to appear below, because you know the X minus S is obviously causing that 0. So we don't want to lose that X minus S above.
Usually it's normally the numerator that we do. That's
Right,
but this,
It can be flipped around, it can still work,
okay.
right? We're gonna do whatever it takes to get the numerator down there to show us the hole.
Okay.
And you're always gonna try to clean up the side that has the radical on it. All right, what's root X minus root S times root X plus root S?
X minus S.
Good. Expand.
Yep.
Expand.
So we're good. Right there. Get along. Be more track.
Okay, what's next?
They cancel out. This is so then you just plug it in.
Final step.
You're pushing my buttons, dude.
Just plug it in. And that becomes 2 S.
Yeah.
Oh.
There we go. See,
In the bank.
Oh, I didn't know.
All right, page 12. Let's just do number 6 on page 12. All right, are we good with number 4?
Crystal.
Number 6 should be easy. You're just plugging in. You should be able to get to your answer just by direct substitution.
You said do 5 too.
No, just 6.
Oh, just.
Yeah.
No 7, right? Just.
We're done. We're done with page 12.
Boom.
Four times 4 is 16. 16 minus 16 is 0. Plus 5 times 0 is 0. Plus 12. I'll do 4 times 3 though. It's the square root of 0. It's 0. Where's the 3 go? Oh, the 3 said.
Wait, what's what I heard of?
That's what I said.
16,
Did you get
16 minus 16, 0. So
That is not what you asked me.
plus,
Oh, number 5.
is it 12?
No, I.
Answer 12.
Yeah, okay.
No, I need.
Oh, sorry.
Thank you. I'm sorry.
Graham, you really got 6 wrong? Come on, man.
No, I included the 4.
Nope.
12, I should not include the
Nope.
12.
Let's do a complex fraction problem. So can we turn to page 16? And let's try 85 and 89. Let me, guys, let me work through this with you. Okay, so So just give me your full attention. Let me work through 85 and 86 with you on page 16.
It's not good rash. That's right.
What? Are we skipping so many?
Page 16.
What did the sixties do to bro?
Guys, up here, please. So here's page 16. Okay. Regardless of the fact that this looks like a complex fraction, we've got to do common denominators. We don't want to skip our first step, right? So first step, direct substitution, right? So we replace what? H with 0, right? H is the variable here. So replace H with 0.
Correct.
So numerator we get minus 1 over x, which is 0. And denominator we get 0. So now we get confirmation that there's a hole. And now we can move into our cleanup stage.
Oh, what do we do for this?
So what we do is we're going to work on this portion first, right? Our goal is to find a common denominator, merge the two fractions, get it down to one fraction in the hopes that an h or some version of h will appear in the numerator so we can pair that up with this denominator h so that we can cancel out.
That's fine.
So let's work on building a common denominator. What's the common denominator between these two fractions?
X times X.
Good. I need both of them, right? Those are completely different denominators. I need both of them to create a common denominator. All right. So now we got to balance our fractions. What's different between the old and my new denominator? What's missing? I'm missing a x, so I need to multiply the top and bottom by x.
And then you're mixing the X plus H.
X
Right.
times 1 is just x.
No, I know, but
Right.
the next one, right?
Yeah, next one. Yeah, next one. The difference between the old and new denominator is the old is missing an x plus h. So I need to multiply the top by x plus h. I'm still going to leave this in a set of parentheses. Why is that? What's helpful about this in a set of parentheses? There's a negative that has to end up distributing through. So we don't want to lose that. We don't want to lose track of that. Okay, so now that I have common denominators, I can merge them into the same fraction. And I can combine my numerator like terms. So x minus h. So that's why it's important that we have the parentheses here. Otherwise, you may forget to distribute that negative through, and you may end up with a positive h. It needs to be a negative h. All right, what does my numerator clean up to be? I can do a little bit more cleanup up here. There's negative h. So now we're ready to go back to our original problem with an updated fraction to work with. So limit as h approaches 0.
2x. X squared.
The H is canceled out.
Are we okay so far with the updated limit statement? We know we're looking for an h, so we do see it, so that's a good sign. But maybe right now it's not apparent that these two can cancel out, so I'm going to get them up to the same level so I can hopefully see a numerator and denominator more clearly. So dividing by h is same thing as multiplying by its reciprocal. So the reciprocal of h is 1 over h, so times 1 over h. Now this becomes more clear in terms of what can pair up and cancel out. H's go away. There's still a what remaining up top though, -1. Now the hole is gone. You can reevaluate your limit. So
Squared plus H.
replace your remaining h with 0. So my denominator is just what?
X.
X squared. Don't forget about the fact that it's in the denominator and there is a negative in front. Okay, try 89. See if you can do this one on your own.
Zero over zero. So many like rules. It's like 3 different rules for like. Who's this now?
It's going to be the denominator that's going to require the cleanup stage, cleanup step.
Understood.
The numerator, you're not going to do any, you're not going to change it. You're just going to leave them as is.
You don't change it to x minus 2, right?
Let me see. What do you mean?
Don't change it if it's inside of the square root.
Yeah, good point. Yeah.
Change it.
You're only, when you're creating your conjugate, only change what's between the two terms, never change what's inside the radical.
The two
Inside the radical, that x plus 2 is not going to change. Yeah. So the denominator is going to expand. X root x plus 2 times root x plus 2 is just x plus 2. Negative 3 times positive 3 is negative 9. Clean up that denominator. You should be getting an x minus 7. That's what we want. We want that x minus 7 to show up below, which is matching that hole that we are expecting in the numerator. Remove the hole, direct substitution with your remaining expression, and then your limit is 6. Okay, now can we turn to page 13? And I want to see if we can build our, this is what a portion of your quiz will look like, just to be able to identify values and limits from a graph, and also to be able to create your own graph based off of the expression, based off of the characteristics. So page 13. Let's see if we can get through all of page 13.
Second one. This would be 5.
That's right. Wait, for part A.
Oh,
Because, right, we're approaching. That means, remember, anytime you deal with a limit, you got to pick 2 points and draw an arrow and ask if the arrows are headed towards the same y value. So here, for part A, I'm picking points on both sides of -7. I'm drawing my arrow. They're not headed towards the same real number. So limit doesn't exist, but we have a subcategory for arrows headed in the same direction. So subcategory for part A is positive.
Okay, all right. So if it's limit, you're
If it's
just,
limit, yeah, pick 2 points, draw arrows, and then base your decision
they
off the
go-
arrows.
but if it's a straight line and there's a
It-
hole,
Then,
then there,
then that's the limit.
yeah,
Right. One's headed towards 7, the other heads towards 7,
yeah.
the limit is 7.
Or if there's not a hole, either or.
If there, yeah, either or, it's gonna be
Okay.
what the arrows are telling you. Yeah.
Do we need this subcategory?
Say it again?
Do we need this subcategory?
Yeah, so I'm gonna specify that for limits that does not exist, if there's a subcategory to identify the subcategory. If there's no subcategory, then you just leave it as DNE. So 2 instances of no subcategories would be, if it's a jump discontinuity, this is just DNE. If the arrows at an asymptote are pointing in different directions, there's also no subcategory. These are both DNEs. The only time you have a subcategory is if there's an asymptote and the arrows are both pointing up or they're both pointing down. Okay, any questions with the top half, A through H? Are we comfortable evaluating our limits and order pairs? Remember, with limits, you want to pick points on both sides, draw arrows, and base your decision off what the arrows are telling you. Don't look at what's happening at that point. Look at where the arrows are pointing. I don't want to rush that second half, that bottom half, because what I want to do is tomorrow at the start of class, I'll let you guys finish number 2 or the bottom of creating your own graph. But also know that every graph may look different and be okay. So after you guys create your graph, I'm going to show my graph, but I'll walk around and check your graph to see, are there any issues, so that you feel comfortable and confident that even though your graph looks different, that it can still be perfectly fine. But if it's not, if it's an issue, I'll point that out on your specific graph so you can feel comfortable. I'm going to check pages 9 through 12 tomorrow. If you did everything we did in class, there's no homework. Okay? Page 11 and 12, we just did the problems that I focused on. So the problems that we skipped over, don't worry about doing anything. So no homework tonight if you did everything in class with us. And then tomorrow we'll do page 13 and 14. And I'll have another worksheet for us to practice on. And then help session is Friday at 7:30. And the quiz is Friday. It won't take the full period, so we may be able to practice a little bit beginning of class Friday before you take the quiz. So have a great day, guys.
David, would this be a dot or you can just connect?
The dot is on the asymptote.
What do you mean?
Any thoughts on that? Dave's not talking.
This is-
Keep going here.
Okay.
Thanks.
All right, have a good day. Thank you. You're good.
Trying to finish up this last.
Yeah, yeah.
This right here. It could either be a dot or it could be a connected line.
And this is just a figure. There's two graphics with that number though, but this is piecewise functions. Oh, sorry, achieve a tweet.
Yeah,
That's in
yeah, so can I connect it to line or?
you can worry about that later. Don't worry about it.
So- So that's right.
Yeah.
We're starting. So we're on this. So he sent out like dates for stuff.
So,
And she's like, okay.
That means both arrows are headed towards that point. So you can just draw the graph and.
so I can just draw this graph, right?
Yeah, just. Yeah.
And
Go past. calculus.
Figure out.
Yeah,
And then 6.
that's an order pair.
I just have a question. So I know the Wednesday and Thursday help sessions are only for BC students, but I'm taking AP Physics C right now and I have a quiz on Friday and we're starting to do like derivatives and integrals and obviously I don't know how to do that yet.
Okay.
Could I come in and I need like just basic like how
Yeah, I
is
can,
that what they're covering in BC right now?
no, we haven't gone that to in BC, but I can,
Okay.
I can go over that with you. What's your lunch?
I have fifth lunch.
Okay, I can do that now with you. You want to do that now?
Wow, we can do
Okay,
it now.
all right, so you can sit up here
I
on the
have
list.
console 4.
Okay.
So I should be fine to do it now.
It says this does not exist. Do I make this a 3?
Remember, there's three scenarios. Either make it a jumplet continuity, make it a vertical asymptote, or make it to endpoint where the graph just ends. What you don't want to do is, you don't want to make it a hole and extend this way.
That's also the same as does not exist, right?
Yeah, so you can make the graph look like that.
Or you can make it a jump. And then if I made it a jump, right?
You can just create two random points where the graph is disconnected.
Would I have to shift it over because of this? Would I have to move it over one?
Is that G of 6 equals 7?
Yeah.
No, you can do anything you want. If you want to make that a jump, I would just take a random point and do that.
Okay.
That's
All right. Thank you.
Yeah, I'll show you some of the problems that we've been doing. It doesn't seem to be too
Yeah, so
complicated. Okay.
Give me a second, I'm going to this room.
Yeah, no problem. I actually need to go too.
We're just reviewing some more.
Yeah, it's reviewing them all.
Thank you.
Cool, I'm here.
So finding a derivative, that's what you need.
Yeah, because we do graphs on acceleration and velocity and they're derivatives of each other. So technically you can do it without calculus, but it takes so much longer. And for physics C, they only require that you take A, B, or BC like concurrently. But obviously we haven't covered those topics yet, and this is our first unit, we're already doing it, so.
Yeah, so we are gonna go into particle motion, which is just essentially position, velocity, acceleration. Like I said, they're just derivatives of each other. So the rule, let's say I had 6t cubed minus 4t squared plus 1/2 t.
Yeah.
The way you do power rule, or the way to find the derivative is you're gonna bring the exponent down, multiply with the coefficient in front.
And then you do, it's like n-1.
Yep, subtract
It'll be
one.
2.
This will be
8, and then I would want to calculate that. And then,
this will be. This is actually a 1 here.
yeah, would you do it to the power of 0?
That's right, which is gonna be just a constant, so
Yes.
it's just, so anytime that, so basically every degree is gonna drop by 1. Degree 3 goes to 2, 2 goes to 1, and then 1 will go to a constant.
Okay.
And then the derivative of acceleration will be 36, right, yeah, 36t minus 7.
Got it.
If I want to find the position at a point, I can plug in the t value to get that location.
Mhm.
If I want to find the velocity at a different t value or the same t value, plug in t, I'll get the rate of change of position and then rate of change of velocity.
Rate of change of- yeah, the
acceleration.
Okay.
Have we gone to, do you need antiderivatives yet as well?
I don't think I need antiderivatives. I know we need to do integrals. So.
Yeah, integrals is antiderivative.
Oh, okay.
So, you're just going, so imagine you're just going up the chain.
Mhm.
Antiderivatives is the opposite of derivatives, so we're undoing our derivative process.
Yeah.
So, for derivatives, you're doing this, right? You're multiplying. And then you're subtracting,
Mhm.
right? So imagine if I want to undo this process, I'm going to add. And then I'm going to divide.
Okay.
So imagine if I have 18t squared. I want to get up to 16 cubed, I'm going to add first. So I'm going to add 1 to that exponent.
Okay.
I'm going to divide by the new exponent that I just found.
Okay.
And now I'm back up to where I came from.
Okay.
So that's your antiderivative. For, at least for power rule. This is what we're gonna learn first. We're gonna learn, power rule, derivatives and integrals for rational functions or for polynomials.
Yeah.
And then there's also derivatives and integrals for other families of functions like logs, exponentials, trig. But for now, I think,
I'll only.
yeah, you only need, yeah, we really this
We're
for.
just in kinematics right now.
Mhm.
So, and we covered that in physics 1. It's just a little more expensive. It's calculus based versus algebra based.
Yeah,
Yeah.
okay. So, anything else?
No, that's
Okay.
really it. That doesn't seem, too bad.
Not too bad,
So
yeah.
I'll probably just do a couple practice problems at home before my quiz.
Yeah,
Just to really drill that in. But yeah, doesn't seem too bad. Thank
not
you.
too bad. Okay, and then, I guess if you have any questions, you can ask me tomorrow as well. But, yeah, I only know, I can only help you on the calculus side of it, not so much on the physics.
No problem. The physics side isn't too bad. I really
Okay.
love physics and I love Mr. Hoja.
Good.
I took him for physics 1 last year. So
That's it.
great class.
Something.
Love the subject.
So, good.
Well, thank you so much.
Yeah, see you tomorrow.
Okay.
Bye, Rachel.
And I like your Radiohead poster.
Yeah. Oh, yeah, I saw you with the Radiohead shirt, Jim. I saw that.
I think I'm more of a Ben's person and the rainbows. But
Yeah, no, Ben's is my favorite, but this has grown on me. Kid A was like, when I first heard it, I was like, what is this? But then
No, it's
over
great.
time.
It's really different.
it's really different.
And I think Pablo Honey gets a lot of hate, but there's really great tracks on it. I love Vegetable.
Yeah.
It's really great. Like Creep is honestly like the worst track on there.
Yeah, I like how their first 4 albums are just completely different from each other. That's just so unique.
Yeah, it's
No,
great.
no bands can do that. And they're
Yeah.
all good, right?
They're
So,
talking about going on tour in
Mm,
Europe. I really
okay.
hope that they come to US. I would love to.
yeah, that would be a dream. That would be a dream if they come to US.
Yeah.
Okay, see you, Rachel. Bye.